So in the last class, I just told you in our data science course, what are the main concepts we are going to be having actually. Actually, the course is full stack data science course. It is actually full stack data science course. I'll talk about what is the full stack data science course. What is the meaning of that full stack? I'll tell you. So full stack is generally, guys, end to end, whatever that is required for in a particular Python, in a data science project, all the requirements. It's not only of a particular part. So in a data science project, whatever that is going to be required, the complete full stack, the complete concepts and the complete whatever that is there, we have to know about them. So as I told you, basically in the data science, we are going to be learning three core areas actually, guys. One is a machine learning, second one is a deep learning, and third one is going to be the AI actually. So these are the three core concepts which we are going to be learning actually, guys. ML, DL, and AI. These are the three core concepts what we are going to be learning actually. That is the basic things what we are going to be learning actually. So anyhow, I told you to understand what is deep learning. Slowly we'll understand them, guys, one after the another. So first I started with the first part, which is going to be ML, which is going to be nothing but stands for machine learning. So what is machine learning? Yesterday we have been just a small introductory part only we have been got taken actually, guys. So what is machine learning? So what is machine learning? I told you. So where the machines are going to learn. So machines will learn them actually, guys. Machines are going to learn. But how they are going to learn actually, guys? How they are going to be learned? So what is data science basically, guys? Data science is going to be nothing but what we are going to call it as a data-driven science. It is going to be a data-driven science. A technology which is completely driven only with the help of the data. So if we have the data, we have a data science. You don't have a data, we don't have any data science. Data science is completely came from the data only, guys. So that means that what the machines are saying is, previously we thought that machines has to be given some program. The machines has to just run the program, whatever the logic we have been written. Now the machines are saying that you need not to write the code for us. You need not to write the code for us. We are capable to write the code by ourselves only. Machines are capable to write the code by themselves. But based on what we have to write. So if you give me the data, based on the data, whatever you have been given, we are going to write the code actually. So in a simple process, I told you, data was there. Data was given to the machine. Yesterday, I told you one small simple use cases I told you. Data was given to the machine. Machine is going to understand the data. It is going to learn from the data, and it is going to give you some kind of an insights. Based on the insights, we can do some kind of a prediction. So a simple example yesterday we have been got taken. So whenever a customer applied a loan, a customer has been applied a loan actually, guys. A customer applied for a loan. So I want a loan amount of so-and-so. And for the so-and-so product I want to buy a car, I want to buy a house, I want to have a personal loan, something. A customer has applied a loan. So his details has been given to the machines. Details are given to the machine. What are his details? His personal details, like how much salary is earning, whether he was married or not. Okay, how many years he's working in a company. All the details are been given to the machines. Machines are nothing but your computers. Now the details are going to be given to the machine. The machine is going to tell you whether to give the loan or whether not to give the loan. So the loan approval will be decided by the machine. So customer applied the loan. The loans, his personal details has been given to the machine. Machine will decide whether to give the loan, whether not to give the loan. So how the machine comes to know? We don't write any program for that, guys. We don't write any program for that, saying that if this is the data, you have to give the loan. If this is the data, you should not give the loan. We are not going to give the hard-coded values actually, guys. The machine has been learned from the past customers' data. So we have a past customers data is there who has been taken their loans and who has paid the EMS promptly and who has not paid the EMS promptly. So it studied their characteristics. Who are my past customers? It studied all the past customers details. Their past customers behavior, they studied it. And based on that particular behavior, the machines are saying that you can give a loan or don't give a loan, whether to give, whether not to give the loan. We are going to decide this actually. So loan approval is going to be gets done. Same as it is whenever it comes to a patient. So whenever a patient went to a doctor or something, or patient is there. So he has been went to a doctor to get some diagnosis actually. So what are is basically the symptoms? What are going to be the basically the symptoms? Here the symptoms are going to be nothing but the inputs what they have been given. Here the inputs are going to be details about the customers. So give them in symptoms to the machine actually. Machine is going to diagnosis. It is going to be diagnosis. Whether it is going to be a positive case of for example so-and-so disease or a negative case for a so-and-so disease actually. How the machines can turn. The machines has been studied their past, whatever the past. What is going to be the past patient's data is there. So based on the past patient's data, the machine was able to identify. So this is going to be nothing but he is diagnosed with a positive for a so-and-so disease and negative for the so-and-so disease. So machines are learning by themselves, but how they will learn actually? Everything should be given as a data format. What has been happened? You tell the system, not in a text format, not in the text format. We have to give it like a data format. Once if you give that data to the particular machine, something different from other programming languages, guys. One thing, machine learning is our data science is not about a programming language. It's not about a programming language. So we are making the machines to study the data. We are making the machines to understand the data. Once if we make the machine to understand the data, so we can just give that, we can make some kind of a predictions. Like another examples, we can talk about them, guys. Like for example, gold price. So which is going to be gold or a stock price actually, guys. So it is going to be the stock market, which is going to be the price, the whatever the investments we are talking about them. So which is going to be a gold price or a stock prices of a company's stock price, what it is going to be. So give the past data actually, guys. So the machine will study. So in which pattern the price of a gold is increasing, at which situation the gold price is going to be decreasing, what is going to be the stock price of a particular company, when it is increasing, when it is decreasing. So there is going to be some kind of an analysis it will understand. It will try to find out the trend. It will try to find out the trends. And based on that, it is going to do the prediction actually. So after 1 year, how could be the price of the gold? How much is going to be the price of the gold, whether it increases, whether it is decreases. So these are generally, we call them as a time series analysis actually, guys. These are what we are going to call it them as a time series analysis. Lot of things are available in our data science course, guys. So we call this particular, I told you, there are so many subtopics are there. So many subtopics are there. So there is a time series analysis is there. What is a time series analysis? Whenever the data was bounded with some time, in this year, this much is a price. In this year, this much is a price. In this particular month, this much is a price. Whenever it is associated with some time and date, we call it as a time series analysis. Like gold prices, stock prices, all these are going to be decided, analyzed, can be predicted based on the time series analysis. So we have a lot of examples, guys. Lot of examples we are going to be having it actually. So data was given to the machine. Machine studies the data. It gives you some kind of an insights. Based on the insights, we can do the prediction actually. That is what exactly the machine will do actually, guys. That is exactly what the machine will do. Currently, we are discussing only machine learning, guys. Sir, what is deep learning? Deep learning is also part of machine learning also, guys. Deep learning is a part of machine learning only. It's nothing but another sub area. It is going to be just another area of the machine learning actually. A little bit complicated. It is also part of a machine learning, but some kind of an complex problems, we kept it separately as a deep learning actually. But deep learning is also part of the machine learning only, guys. Deep learning is a part of the machine learning. So we are learning machine learning means as part of machine learning, we'll learn the deep learning part also. Okay, fine. Anyhow, slowly we'll understand them. Slowly, don't worry about them. Now the thing is, sir, if everything is done by the system, then what is my work? So data was given to the machine. Machine is going to take the insights. Machine is going to study the data and it is going to give the insights, and machine itself is going to do the prediction actually. So if it is possible, guys, today I'll just show you one small example also, just a small example to make you understand the technical aspects. Okay, anyhow. So if everything is done by the machine, what is going to be our work actually, guys? You should be knowing some kind of a techniques. That means machine learns, but we have to create the environment such a way that the machines can learn. That means machines can't study all the data as it is. Whatever the data was there, if I give it as it is, machines can't learn it. We have some input to the machine. We have to give some, at least some basic input to the machine actually. So what are the basic techniques we have to learn it actually? They are not technologies. we have to be having some kind of techniques. Some kind of techniques we have to learn it actually, guys. Yesterday I told you, what is data science? Data science is all about studying of some kind of techniques, some methodologies, and using some kind of systems, using some kind of algorithms to get some insights from the data, to get some knowledge from that particular data, basically based on which we can do some kind of predictions. So what are the basic techniques we have to learn it actually, guys? What are the basic techniques we have to learn it actually? I'll tell you some few techniques actually, guys. Whatever it may be the machine learning algorithm, whatever the task we are doing, process is the same process as it is. Only the thing is, the way which we do it is different, but process is the same process. So the first technique actually, guys, the first technique it is going to be nothing but data collection. The first thing is going to be nothing but it's a data collection. So first of all, as I said that we have to give some data to the machine. But who is going to give the data to the machine? From where the machines are going to get the data? So first of all, we have to get the data actually, guys. We have to get the data, which is done by the user. A user is going to, user means manually we have to do it actually, guys. Sir, data collection, it's very easy. No, data collection is not that much easy nowadays actually, guys. Because nowadays, the data is not coming purely in a structured format, guys. The data is not coming in a purely structured format. If data is purely comes in a structured format, anybody can read the data, anybody can collect the data. But nowadays, data is coming in a different formats actually, both structured and it is going to be some kind of an unstructured format. So don't expect that data will come just like a tabular format, something like an Excel format or just like something like a CSV format. No, we are getting the data in a different formats actually, guys. So here we are going to learn all the techniques, how to extract the data from the various systems. Like it is going to be normally from local systems like CSV, Excel sheets. Okay, not only that, even some kind of a database systems, or it is going to be some kind of an cloud storages. It is going to be some kind of an cloud storages. You can use some cloud. Nowadays, everybody is using cloud storages actually. Cloud storages. Some people are using some like a formats like JSON or some kind of an formats like a SAS, or it may be some kind of a statistical analysis tool like SPSS, Stata. So many things are going to be there actually, guys. It is going to be Stata, etc. There. So what we are trying to do is we'll try to learn all the different possibilities. So if the data is available in different possibilities, how to extract the data actually. We'll tell you all the techniques actually, guys. What are the problems you are going to face at the time of reading the data? What are the techniques we have to follow? What are the solutions for that? What kind of concepts we have to implement them? So that is what we are going to learning it actually. So data collection is not that much easy nowadays actually, guys. Simply don't think that data is there in a CSV file. You can just read it. No, even if the data is in CSV file also, there are a lot of issues will be there. We have a lot of issues will be there. How to handle that kind of an issues, how to handle them, and how to solve the particular issues, we have to study them. So the first task important is, guys, what is your data? So according to your task that has to be given, where is your data is there? How to collect that particular data? So data collection, we have to do it actually, guys. First, do the data collection actually, guys. Next, once the data was collected, that means once you have collected your data, first of all, we have to analyze the data. Analyzing means understanding the data actually, guys. Why we have to understand the data? Because first of all, if we understand the data, we can give the instruction to the machine. For example, in our school days, we have been given the training from the student, from the teacher. First of all, the teacher should know how to solve a problem. Then only the teacher can guide the student. Same as it is. First of all, we have to understand what are the issues with the data. Is the data is in a proper format, such a way that the machines can learn. If it is not in a proper format, what we have to do? So that is going to be comes under some kind of an data analytics. We have to analyze the data. A lot of analytics actually, guys. Main important in our data science is your analytics part. Your main important is going to be analytics part. Analyze your data. Understand how is your data. What is the data we never bother about, guys? What is the data we never bother about? How is our data? So it is going to be there are some statistical analysis, there are some mathematical analysis are there. We'll see them. What are going to be the statistical analysis? We have to do that. Once if you analyze the data, we'll come to know what are the main issues with the data actually, guys. So main issues, as I told you, today's the data is going to be not in a proper format. It is not in it's not in a correct format also. Sometimes structured, sometimes unstructured. Sometimes it is going to be some wrong data will come. Some kind of an irrelevant data will come along with our data sets. So we have to identify all that kind of an issues we have to identify. And we have to just do some kind of a techniques. That is nothing but what we are going to call it as a data cleansing. We have to do some kind of a data cleansing. We have to do it actually. Cleansing is nothing but we have to clean the data. So data is going to be dirty data actually, guys. Your data is going to be dirty data, or what we call it as messy data. So whenever the data is going to be in which is going to be dirty or a messy format, we have to convert this into a tidy data actually, guys. A clean data. We are just doing some kind of a cleaning. You know what is tidy? So it is going to be nothing but which is going to be untidy and tidy. It's a clean. So there is an untidy data is there. A dirty data is going to be there, or some kind of a messy data is going to be there. So some kind of a messy data is there, which we cannot understand in a proper structure. Then what we have to do that? We have to go for some kind of an tidy data. How to clean that particular data actually, guys? Put it in a clean format actually. Because machine always requires a clean data. If you just give some unclean data or something irrelevant data, they will learn in a wrong way actually. That's why we have to do the data cleansing. So collect your data, do some data analytics. We understand some issues with the data, clean them if it is required. If it is required, you have to clean it. If I don't have any issues, I need not to clean it actually. To understand the data in a better way actually, guys. That means analyzing the data is a fine. It is a text-based analysis, and all these are nothing but what we call it as EDA. EDA is nothing but exploratory data analysis. All these are going to be comes under a part of EDA, exploratory data analysis. We use a term called as an EDA here, guys. Sometimes to understand the data in a better way, we use some kind of a data visualization actually, guys. We do some kind of a data visualizations. Visualization is nothing but putting the data into visual context. So data, we cannot see it. That means some data, normally patterns cannot be detected. You cannot detect the patterns actually, guys. We cannot detect the patterns. But if we visualize them, we can detect the patterns actually. How the data was there, how the data was related. So we use the data visualization. Basically, we are not developing any business reports actually, guys. We are not giving any business reports to the client. To understand the business, our data, to understand how our data was there, we are going to do some kind of a data visualizations. So putting all the data into a visual context, we do data visualizations. So collect the data, analyze the data, clean the data. To understand in a better way, you have to go for a data visualizations. So all these are going to be done manually by the user. Machines can't collect the data. Machines can't do the analytics. Machines can't clean the data. Machines can't visualize the data. So once if we have done, and once the data was ready to learn, then we are going to give the data to the machine. And that particular step is going to be nothing but what we are going to call it as training actually, guys. Train. It is going to be train the data model. So where the machine is going to learn. The machine learns actually here, guys. This is the step where the machine will learn actually. Train the data model. Just we'll say train the data model. Don't think that we are training the data model means we'll write a lot of code, guys. We don't write any code at all. We don't write any code at all. Majority of the work is related to data analytics, data cleansing, data visualization. This will take more time. EDA part is almost all contributes around 80% of your project time actually, guys. 80% of your project time is involving only this contribution only. So collecting your data, first of all, understand where is the data is available, collect all that particular data, do some analytics part, identify the issues, clean the data if it is required, do some data visualizations for a better understanding. So training the data model is very simple. If it is only just 1-2 lines of code only, we don't write any functional code here now. So training the data model is very easy. But which models we have to use? what is the way the machine has to learn. All these things we have to study by ourselves. So we will decide actually, guys. And already I given an idea about them. Already I have given some idea behind them. How the machines learns. Machines cannot learn by themselves. There are going to be some kind of the predefined. There are going to be machine learning algorithms are there, guys. It is going to be algorithms are there. You generally have an idea about what is meaning of an algorithm. An algorithm is going to be nothing but a flow chart. Just it is going to be nothing but a sequence of steps to solve a particular problem. So hope you, while you're learning C, C++ languages, they'll tell you about what is flow chart, what is an algorithm. An algorithm is nothing but a sequence of steps to solve a particular problem. So to solve this particular problem, these are the steps we have to do that. Here also, guys, we will take the help of ML algorithms. In deep learning, we are going to use a DL algorithms. In deep learning, we are going to be using a deep learning algorithms, where we are going to call it as the neural networks, what we are going to call it as. We are going to call it as a neural networks, what we are going to call it as. Sorry, a neural networks. Whereas in machine learning, we are going to be using a different types of, in machine learning, we are going to be using a different. So neural networks are also going to come under machine learning only, guys, but there are separate algorithms, no? That's why they kept it separately inside the machine learning concept actually. So we are going to learn, our main concentration is on this machine learning algorithms only, guys. These ML algorithms and the deep learning algorithms. Mainly, we are going to concentrate on this particular algorithms. Study about the algorithms only, guys. These are all the simple tasks only, guys. But how to study what the machine learning algorithms will work. So main concept is that one only, guys. Just if you simply apply the algorithm, that is not sufficient. We have to study what are going to be the algorithms actually. Yes, we have it. So in neural networks, we have ANN, it's an artificial neural network. CNN, which is a convolution neural network. RNN, which is going to be a recurrent neural networks. But all of them are neural networks only. But again, we have a different types of neural networks. So that's why what they did is they kept separate these neural networks as a deep learning algorithms. So all the neural networks are going to come under the deep learning algorithms actually. Okay, fine. So that is the next level. That is the next level. We'll see that ANN is nothing but artificial neural networks. CNN is going to be what we call it as in convolution neural networks. Okay. So here the machine is going to be get trained. And here we are going to study actually, guys. The main interesting part is going to be how the neural network will learn. Neural networks are learning. They are learning actually, guys. How it is going to learn. Very interesting topic actually, guys. Very, very interesting topic. So maybe while you're studying the maths, maybe in a 10+2 or in a 10 standards, you may not have an idea why you are learning the things actually, guys. Why we are going to be learning the things. Like normally everybody knows that what is going to be derivative. What is going to be nothing but a derivative concept actually. We have learned derivatives concept in our calculus. At that time, we have been learned how to do the derivatives, but really what is the real scenarios of the derivatives concepts? Why do you really learn that particular derivatives concept actually, guys? We all of you know that what is going to be derivative and how to calculate. What is derivative of x square, let us say, which is going to be with respect to the x. We say that it is going to be 2 into x actually. But what exactly the derivative means? How exactly these derivatives are used in our real scenarios? Your neural networks is going to be based on this concept called as an derivatives concept only. It is going to be depending on that. It's going to be depending on the derivatives concept only, guys. So normal machine learning algorithms is going to be a different concept. So how the networks will learn, how a neural network will learn, how a deep learning models is going to learn, and how a machine learning algorithms will learn a different types of algorithms, guys. I'll write some few names. Don't worry about them. It's completely new terminologies, guys. It is going to be an algorithm called as an KNN, which we call it as an K nearest neighbors. We are having some algorithm called as an Navi Bayes. We are going to be having some algorithms called as an decision trees. The names are going to be something different actually, guys. The terminologies are completely different. How a KNN will work. What is Navi Bayes, how it will works. When to use decision trees and when not to use a decision trees. So many are going to be there. What are the issues with them? Some kind of a names like random forest. It is going to be some kind of a names like a random forest. So many are going to be there actually, guys. Bagging, boosting. So names are going to be a little bit funny names like boosting, bagging, and so many are there actually, guys. Like we are having something called as an regression, linear regressions. These are all machine learning algorithms, guys. Linear regressions, where we are having a logistic regression, or we are going to be having a lasso regression, or we are having something called as an ridge regression. Like that, we are going to be having a different types of the algorithms are going to be there. So data science is all about learning these particular algorithms only, guys. Algorithms, methodologies, techniques, and some systems. They are not technologies, guys. We are not learning any technology here now. Even if you see, just go to, if you see, what is data science actually? So when you search for the data science, it tells only about that one only, guys. It is all about studying of, understanding and learning of some scientific techniques, some methodologies, some different type of processing techniques we are going to use. We are going to use them, guys. So data science is an interdisciplinary field that uses some scientific methods. We are going to be using some, no technology will be there. We are going to learn about different processing techniques, algorithms, and systems to extract the knowledge and insight from the noisy, structured and unstructured data actually, guys, and apply the knowledge and actionable insights from data across a broad range of application domains. You can apply them actually, guys. All of them are going to be relevant to some maths and stats is going to be there, which will study that applications later. Okay. It is all about studying about some techniques only, all about studying about the methodologies, what we are going to be learning. And in neural networks, in deep learning, we have a different names. So many are there. It's not only these, even we are having so many interesting topics will be there. So these are the some of the algorithms, guys. Support vector machines, we call it as an SVMs. Support vector machine. These are some of the commonly used machine learning algorithms, guys. Coming to neural networks, we have a different algorithms like LANN, we are having CNN, artificial neural networks, convolution neural networks, recurrent neural networks, something actually, guys. LSTM, so many are going to be there actually, guys. Don't worry, encoders, decoders, okay, autoencoders, decoders are going to be there. So many things are going to be there. Really will enjoy the course when you go to the deep learning, guys. Really will enjoy the course once you go to the deep learning. While you are learning machine learning algorithms, absolutely, you will be having a kind of an new topic, no? So little bit difficulty will be there. But once you go to the deep learning, we really enjoy the particular course. We really enjoy them actually, guys. So everything with the real life scenarios, we can do them. Completely with the real time scenarios, we can use them applications. Okay. So anyhow, we are all learning about these algorithms. So if I simply tell you this is a KNN algorithm, apply them. Applying a KNN is very easy. But how to control the KNN? So in which scenarios it is working good? In which scenarios it is working bad? That means it is learning or not learning properly, only we have to verify that. So train the data model. It is nothing but we are giving some training to the machine based on the data, whatever we have been given actually, guys. Once the training was done, it is going to be developing an ML model. One model is going to be gets created actually, guys. So our main task is to make the machine to develop an ML model actually, guys. The outcome is of a machine learning is nothing but an ML model. It's not a exe file. It is just an ML model is created. What is an ML model contains? It just contains what are the insights actually. What are the insights about your data that ML model will contain actually. So what the machine has learned, what the machine has been got understood, that is there in the ML model actually. Now that ML model can be used for prediction purpose. For example, I given the past customers data. This is my past customers data. I collected all the past customers data. I clean all the data in a proper way and I analyzed the data and I given to the machine actually, guys. Now the machine is going to comes with some ML model. One ML model is going to be gets created actually. This model tells about how this particular customer's behavior was there. This model will tell about how the customer's behavior is there. Now this ML model can be used for prediction purpose. So whenever a new customer applies a loan, give the information to the ML model. The ML model will tell you whether to give the loan, whether not to give the loan. So ML model is nothing but your product actually, guys. It's a final product actually. Once if the ML model was given with some new customers data, the ML model will matches with these insights. Based on the insights, it is going to tell the prediction actually. But before releasing it to the real, that means before releasing it to the real world, first of all, what we have to do is we have to test it. That means how effectively the prediction is going to be gets done. How much accurately the prediction is going to be gets done. how exactly it is going to be. That means how much extent it is working properly. That is what we have to test it actually. The testing is going to be nothing but we call it as an evaluation. A very interesting topic actually, guys, because so many new techniques we are going to learn. Evaluation of model performance. Evaluation of model performance. There are so many statistical techniques are there. All maths and statistical techniques only. Just we have to understand what is the technique, why should I use it, and how to implement it. So evaluation of model performance, meaning that is how much extent these particular insights are correct. We have to verify them. It's like a testing the model actually, guys. Here we are going to use some kind of a terminologies, guys, like training, and we are going to be using validation, and we are going to be using testing. These are the some of the terminologies what we are going to use it. So in our normal applications, like we use development, and we are going to use a development, testing, and production. Here it is going to be training, validation, and testing. Some kind of a terminologies. Later we'll see that. This is what we are going to call it as evaluation of model performance. So how good the model is working. So how effectively the model is, it is going to be predicting the data actually. So we have to evaluate the model performance. Okay, it is giving 70-80% accuracy, guys. Observe carefully, guys. Normally in our programming language, let us say that in our programming language, I ask you to write a program. If I give 10 and 20, your output should be coming as a 30. Just an example. If I give the input as 10 and 20, your output expected is 30. But the program, whatever we have been written, has been given 29.99, for example, just an example, or even 25. So I have written a program. When I given the input as 10 and 20, we have got 25. Expected value is going to be 30. In our normal programming languages, we say that your expected value is not matching with the actual value. So simply it is going to be an error. That means the program is not working at all. We simply reject the program. But in machine learning, it's not like this actually, guys. We're expecting 30, but we have got 25. How much closer this value is going to be to the expected value? We expected 30, but we have got 25. Let us say that it is closer by 80%. That means your model is working 80% accurately. Your evaluation, your score, the score of the particular model actually, which is 80% only. You learn something, but whatever we learn is only going to be accurate only by 80% only. Your marks, just like a student marks. So student has been trained in the class, and that has been student is evaluated by putting an examination. So student is evaluated how much extent he has been learned in the class. So we have to evaluate just by putting some examination like testing and validation. So what is your score? How much going to be your score actually? The score is going to be nothing but 80% or 90%. You are closer to the expected value, but by 80% or by 70% or by 60%, something like that. So we'll accept the model. Even we are expecting 30, even if you got 25 also, we'll accept it. We don't reject it. We don't reject it. Simply saying that you are almost 80% closer to that. You are almost 90% closer to that. So we'll accept you. But you are 80% closer. If there is any possibility why it is giving only 80%, we're expecting 30, why you are getting 25, what is the reason? If you study them, you can handle that kind of a situations. From 25, if I can reach to 28, I may not reach to 30, but if I reach to 28, at least you are 90% closer to the expected value. That means your score has been increased from 80% to 90%. That is what we are going to call it as improving of model performance. Improving of model performance. A very interesting topics actually, guys. Improving of model performance. This is what exactly we are going to do that. Improving of the model performance. These two are very interesting topics actually. An interview point of view also, guys. There are very interesting topics actually. There are very important topics also. So really, if the interviewer want to know how much skill you are having in the data science or how much skill you are having in this particular subject actually, only these two topics are sufficient. You can completely evaluate what is the knowledge of that particular the candidate. Because all these are conceptual based, guys. You have to understand the concept. Implementation is very easy. Implementation is very, very easy. But what is the concept behind that? If you understand them, then only we can handle that kind of an applications. So these are going to be the 7 steps actually, guys. You see any workflow. whether it is a machine learning workflow or a deep learning workflow or the AI workflow, whatever it may be, the concept is going to be the same actually. First, collect your data. Do some analytics on that. Clean the data wherever it is required. If you want to understand the data a little bit more, visualize them. And then what we have to do, train the data model where the machine will learn and comes up with a ML model. How effectively this ML model is working. If you want, we can see the data actually. How effectively the model is working. So we have to evaluate the model performance and we have to improve the model performance. So these are the steps actually, guys. Out of these 7 steps, 6 steps is done by the user only. This is also done by the user only, guys. Actually, out of the 7 steps, machine is only learning, guys. Machine is only learning. That is an automated process. But to make the machine to learn, whatever the environment that requires, that is what we have to create it. Machine learning is just like how do you grow the plants, or how do you grow a tree? How do you grow a tree? So generally, to make a plant to grow, we don't give any instruction. So today you grow, today you have to give me a flower, today you have to give me a fruit. We don't give any instructions. Only thing is plant knows how to grow, when to grow. It already knows about them. We have to just create some kind of an environment, a clean environment, put some waters, the environment only we are going to be creating actually. Based on that, it is going to be there. Yes, I can tell you about the ML and the DL, but DL is going to be a different. It's one subject. It's a separate area. But as I told you, which I'm going to take 1 or 2 days, it is going to take it actually. Maybe deep learnings are going to be a little bit different networks actually, guys. So technically, I don't know how much extent you have the knowledge about them, Pathak. And it requires a little bit. That means some knowledge about machine learning. If you don't mind, anyhow, I'll give you the introduction about what is deep learning now in the introductory part. But later, that means maybe in the tomorrow's class or something like that, we'll make. First of all, we have to understand what is machine learning. Because without learning machine learning, we can't go for a deep learning. So in a simplest way to make you understand them, guys. In a simplest way to understand. So I'm not talking about technical aspects actually. Previously, what I said is, you have to give the, like for example, predicting whether the person is a defaulter or not a defaulter. Whether the person is a defaulter or not a defaulter. What is the main important features we have to tell? Like what is the age of the person? What is going to be the age? What is the gender? And what is going to be his salary? What is going to be his existing credit cards, number of existing credits? What is the housing type he's staying? Is there any dependents are there? Etc. etc. What is the loan amount? For what purpose he was taking the loan? These are the information. So the data is like this. Age, let us say 30 years. Gender is a male. Salary is going to be 20K. Existing credit 0. Housing is a rented house. How many dependents are there? Yes. How much amount of loan he require? Let us say 2 lakhs. For purpose, he want to buy a car. He want to buy a bike. Something like that. He is having the data actually, guys. Yeah, Rohit. Anyhow, we have a recorded videos. Only one session is a recorded classes. Only one session happened. That too, it's only introductory part. And don't worry, guys. This is only some basic introductory part. When I start with the machine learning, I'll give a complete introductory part. The complete introductory. 3-4 days will completely use the terminologies. Currently, I'm not introducing any terminologies for you. But later we are going to give it. But anyhow, don't worry. Who has been missed yesterday's class? My backend team is going to send you. They are going to send you one mail. They are going to send you some mail. They are going to be send you. In that mail, you are going to get all these recorded videos. Maybe it's not today, because once the demo classes are completed, they will send you a follow-up mail. Will send you. So just to make up follow you. So there are going to be just follow-up mail. They will send you. In the follow-up mail, you will be having the whatever the linked videos are there. The links are going to be get sent it to you. Okay, you can get it from there. What technology? As I said, no, we are not learning any technology here, guys. The data science is not about a technology actually. It is not about a technology. It is some kind of a techniques we are going to learn it actually. But okay, you may be asking about what technology you are using means. It is actually, data science is not about a technology actually, guys. It is going to be some math and statistical techniques, some methodologies to solve a problem, basically for prediction. Basically for predicting actually, guys. Okay. Now let us come to this example. So let us come to this example. So generally the data is going to be like this actually, guys. The data is going to be like this actually. Generally, this type of data, we use it in machine learning. This is going to be nothing but your machine learning tasks. In deep learning application, guys, the data is not going to be like this. Your data is not going to be like this. Simple to understand that we are going to give some images. I'm going to give some images of something called as an cats and dogs. Let us, just an example I'm talking about, guys. Images of cats and dogs. We'll give some images of cats. We'll give some images of dogs to the machine. What we are giving the input actually, guys. We are not getting any data like this. Some kind of a raw files we are giving actually, guys. Images are given to the machine. Machine studies the data, studies these images. You may get it out, sir, how the machines will study the images. We have the techniques is there. So the machines is going to study the images of cats and dogs. And once if the model, that means model is created, a DL model is going to be created. And based on that particular deep learning model, the machines can predict. That means it can identify. Whenever I give an image, it will tell you whether the image belongs to a dog or whether the image is going to belong to a cat actually. Machines are going to study the images actually. Not only images, once if it can understand the cats and dogs, it can identify. I can give some images of Vamshi, myself, or it may be some X person, Y person, or Z person. You give these 4 images to the machine actually, guys. Machine will study. So how the face of Vamshi looks like, how the face of the X person looks like, how the face of Y person looks like, and how the face of Z person looks like. So once the machine learns from that, tomorrow when you give a new image of Vamshi or X or Y or Z, machine can tell you, this is an image of Vamshi, this is a person of X, this is a person of Y, this is a person of Z. So I think you can understand why do you require this actually, guys. So you know that. So how the generally attendance is there. So earlier days, there used to be normal handwritten attendance used to be there in offices. So the person has to go and he has to sign up. After that, in place of that, we have got the ID cards actually. So ID cards are going to be nothing but we have to carry the ID card. Every day we have to carry the ID card and scan the ID card. Now in the place of ID cards, you need not to carry any ID card now. Just it is going to be your thumb impression, right? It is going to be nothing but a thumb impression actually. So just no ID card. No ID card is required. Even if you forgot your ID card also not a problem. Go to your office and put a thumb impression. Now in the place of the thumb impression, no need to do it. So at the entrance, there is going to be camera will be installed. So once if we enter into the office, immediately it is going to be get registered with it. So attendance is going to be marked up. Okay, so and so Vamshi has entered the office at so and so time. No need to just put the thumb impression also. Just you make the entrance through the gate. So there is a camera is installed. Immediately it will identify who is the person is there. Person detection, the person identification actually. So who is the particular person? We can identify that. But before going to that, we'll take some images and we'll give it to the machine actually. So in a class of students, so every day, how many students are coming? Who has been attended? No need to do anything. There is a camera installed. No need to take the attendance. So there are 50 students are there. So teacher is going to call the names and student says that present madam, yes sir, present sir. Instead of that one, not required. There's a camera installed. Just directly it is already trained. The machine was already given some training with the images. It will identify who are the persons in that particular class. It automatically sends in an Excel format saying that this person attended, this person attended, this person attended. Over. So those kind of an example. Technically speaking, it is a different actually, guys. Technically speaking, it's a different concept. So machine learning, deep learning. So if you have the technical aspects of that, so machine learning models can understand only the linearity in the data. All these machine learning models, what we're discussing. Neural networks will study the non-linearity in the data actually. It's all the linear models are going to be the machine learning models, the traditional machine learning models. The non-linear models are separated and they're what we are going to call it as a deep learning actually. There is a technical aspects, but what is linear models, what is non-linearity in the data? Right now you can't understand the particular aspects. But something different. We are going to work with images. We are going to work with audios. We are going to work with videos. And we are going to work with the text. These are going to be some kind of the inputs what we are going to learn in the deep learning models. Yes, all these are going to be, okay. These are going to be nothing but, so what is that Python? What is a pandas? What is an NumPy? They are nothing but, that's why I'm coming to that particular point, guys. I'm going to be coming to the particular point. So I told you about how to do the, we have to learn a data collection. We have to do the data analytics. We have to do the data cleansing. We have to do the data visualization. Sir, how do you do it actually? Will you use any software? No, we don't use any software for that. We are going to be using some kind of an open source languages are there. Most popular is going to be Python actually, guys. The most popular is Python, and next to the Python, we are having R. These are the two languages, guys, which provides all the functionalities that are required in our data science. Whatever the functionalities you require in your data science, all the functionalities are provided by the Python and R. They provides all the utilities actually, guys. So I told you, do you want to do the data loading? Sir, from where you want to do the data loading or data collection? Where we are going to do that? With the help of Python, with the help of R, we do that. Python is a language. I'll tell you about Python is a language. I'll talk about Python later actually, guys. In a couple of days, we'll start with the Python. So we use as a Python actually. So data collection can be done with the help of the Python. Same as it is, all the techniques. Whatever I told you about the 7 steps, data collection, data analytics, data cleansing, data visualizations, all these things we can do very easily with the help of the Python. Even for machine learning, deep learning, evaluation, performance improvement, all these are going to be done very easily in the Python. Python provides you some kind of a libraries. Python provide you some kind of a libraries that are going to be gets provided. We call it as libraries. We call it as modules. There is a difference is there. Don't worry. We call it as packages, etc., etc. So to do all these functionalities, we are going to be having some kind of a libraries are there. So that is what you are talking about that. Like we have a NumPy, we have a pandas, we have a matplotlib. Obviously, we have to learn about them. Without learning them, how can you learn it? So matplotlib is for data visualization. Pandas for data collection, data analytics, data cleaning, all these things we are going to be working with pandas. For machine learning, we are going to use sklearn. For deep learning, we are going to use Keras. We are going to be using TensorFlow. We are going to be using PyTorch. So these are the libraries, whatever that is required for implementing them actually, guys. If for implementing of NLP, it is going to be NLTK, or we are going to be having text blob. So these are some of the libraries which we are going to be using basically for our applications actually, guys. Python is providing all these utilities for that actually. Yes, if we have a knowledge about Python, we have to do it. And don't worry about them, guys. Don't worry about them. Because in our course curriculum, we are going to teach you the Python actually. So you need not to learn, you need not to already have an idea about Python. Even if you are new to Python also, no problem. Because as part of our course curriculum, that's why we are calling it as an full stack, guys. Full stack means from end to end, from beginning to ending, whatever we require. So first our classes will start with Python. But whatever the Python I'm going to discuss here, with this knowledge, you can't become a Python developer. You can't become a Python developer. How much Python that is required for our data science course? Only up to that extent only we are going to take it. Simply I can say that it's a core Python actually, guys. So don't worry, my backend team is going to share you the details actually, guys. They'll share you some details about what is the course curriculum. They'll share you all the complete details they will share you. And today also I'll show you that particular course contents ones, completely what topics we are going to be learning. Not only this, guys, there are so many other things are also there. I'll just show you once so that you can get some idea behind them. Some people are having a doubt. So like what topics we are going to discuss about them. So just I'm going to show you some complete Excel sheet. My backend team will share you. My backend team is going to share you these particular details actually, guys. So this is my total course curriculum actually, guys. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Almost all I divided this into 13 modules. I have been divided actually, guys. First, initially I'll start with core Python, which will be around 12 days of time. NumPy, it is going to be 5 days. Pandas is going to be 12 days. Data visualization, it is for 6 days, guys. In the data visualization only, we are going to be using all that. It is going to be the data visualization by using a matplotlib or by using Seaborn. So many are there actually, guys. We do it by using a Seaborn. We have a library called as in Seaborn. We are having a library called as in Bokeh. Not only that, even we are having something called as in Plotly and a Dash is also available. It is also basically used for the data visualization only. We do it actually. So mainly the machine learning actually, guys. The main two important topics are machine learning and deep learning, guys. These are the two important classes actually. Mainly, almost all, if you can see 31 plus 22, almost all 2 months, we completely learn about machine learning and deep learning only, guys. So even there is an introductory part of, not introductory, even I was an expert in R language. If you want, you can just learn R at most case, as much extent you can learn. So if you're interested to learn, because so many people won't show the interest in R language, but I'm going to teach you the R language. Almost all, if you learn Python, learning R is going to be very simple. Separately, we are having a concept called as an NLP for 1 week. Plotly and the Dash, even Hadoop and Spark is also there. How to develop the chatbots, how to use the Azure ML and Power BI. These are all the tools what we are going to be. Not some of them are tools. Power BI is a tool. Remaining all of them are going to be some frameworks and libraries only we are going to use it. Except Power BI, remaining all of them are going to be the frameworks only what we are going to use it actually, guys. DSA. Can you explain what is the DSA? Srivastava, what do you mean to say DSA? No, it's not data structure algorithms, guys. These are machine learning algorithms. These are going to be machine learning algorithms actually, guys. Okay, those algorithms are different. So don't compare with the data structures algorithms. It's not relevant to data structures. Don't think that algorithms means data structures. We have a different types of algorithms are there. So here we are going to be learning is a machine learning algorithms. Deep learning algorithms is what we are going to be using them. Okay. Yes. Little bit Sindhura, it is going to be little bit SQL knowledge. It's not a mandatory. It is not a compulsory. First thing is, it's not a compulsory to know the SQL knowledge, but whenever we work with some kind of a Power BI tool, a little bit SQL is required, which I'm going to teach you the basics of SQL. It's not mandatory to learn it actually. Yes, it is Monday to Saturdays classes, 7 days a week, because we have a lot of topics are there. So we have to complete off within 4.5 months means at least we should be having 6 days a week. We should have it actually. Okay. Fine, guys.
Sir, one question.
Yes, Srivastava.
So the DSA in the sense like for complex coding, I'm asking like data structure algorithm. That's algorithm side. So it is
okay. I understood
like
that.
Yeah, tree graph something.
Yeah. I understood it. Basically, those are going to be. That means here the basic idea here is we are not going to develop the algorithms. Like for example, what is KNN, what is the decision trees? These are already internally. So I understood your point actually. The graph algorithms and all these things are going to be there. We need not, yes, some algorithms are going to be using the graph models actually. Like we have some association rules are there. Internally, it is going to be used as a graph model. So we really don't require to know that because internally it may use as a graph algorithm, but we don't require to study about them. Who generally requires here is basically who wants to move towards the research side. So if you are planning to do, so many research associates are going to be working with them, guys. If you really want to go to the research, if you are going into the research like PhDs and doing that, then those people has to know about the internal parts of that. So here, whatever the algorithms we have been discussed, we are not developing them. They're already developed. We are going to be using them. So whatever you are asking about the data structures you are asking, they are required whenever we want to develop an algorithm. But here we are not developing the algorithms. We are using the existing algorithms to solve a problem. So for implementation, it's not required. But tomorrow in the future, if you are planning to go to research, because deep learning and all these things will be learned by so many research associates. So if you want to develop, if you want to do a research, and if you want to develop a new algorithm by yourself, then you have to require the knowledge of data structures. Otherwise, it is not required. Okay, Srivastava?
Okay, sir.
Fine, guys. So this is going to be the basic idea, guys. Okay, anyhow, mainly the language is going to be Python and R. So anyhow, don't worry. You really don't require don't know Python also, don't worry. Because I'm going to teach the base core Python, I'm going to teach you. I'm going to teach you for about approximately 12 to 14 days. I'll teach it actually, guys. That knowledge is sufficient. That knowledge is sufficient to manage the manage all the things actually, because all of them are going to be comes like a libraries, guys. All of them will comes like a libraries. All of them will come just like a packages. Only thing is we have to import them and we have to use them. Really, you don't require to play. You write any functional code for that. Ready to use functionalities will be there. As I'm saying that we have to study only the basic. That means the concepts we have to learn it, the methodologies we have to learn. Why we are doing this? If you know why we are doing that, implementation in Python is very easy. Implementation in R is very easy. That's why we are going to do all these machine learning and data science related concepts with the help of Python and R. Mostly Python is more popular actually, guys, because Python provides you a lot of functionalities related to deep learning. If you are only, your knowledge is only for machine learning, so R or Python, both of them are same. But if you want to go to the deep learning models, better to go for Python, because Python provides a better functionalities by using Keras, TensorFlow, PyTorch, and NLP. NLP can be given by both, can be handled both by Python and R, both can handle it. NLTK, TextBlob. These are going to be some of the libraries, whatever that are provided. So in Python, for any implementation, we require these libraries, guys. Why do you require NumPy? Why do you require Pandas? What is Matplotlib? What is Seaborn? What is sklearn? What is Keras? What is TensorFlow? All these are going to be the libraries which are provided by Python communities. Just download them, install them, import them, and start using them. No need to write any particular codes. Okay, guys? Yes, Amit, we have a very good opportunities. Right now, we have a very huge demand for this data scientist. Very huge demand. But the most of the, one of the main concern by so many people is, guys, initially the main plan is they start learning the course like expecting like Java, C, C++. They'll start their particular course like this. But after entering the course, they come to know about that. It's not just only learning a Python or not learning a language. So we have to learn some maths and stats. So a lot of things are there. It's not over just by learning some machine learning. We have to go to deep learning, NLP. There are so much, it's a very vast area actually, guys. Learning within 4.5 months is not sufficient. We are getting some knowledge about them. But if you want to get a real implementation, we have to little bit work more on that actually. So many people expecting like learning a programming language. So you can get some code. So tomorrow, if you get any problem, so go to some online portals, get the solution, copy the code and paste it here. That does not work here, guys. It is completely only for the people who are having a good knowledge, conceptually understanding. If we can understand the concept, implementation is very easy. It's not about programming language. Understanding the concepts, understanding the methodology, what it is, why we are using. If you know that, implementation is very easy. It's a completely conceptual based job. So that is the reason most of the people are unable to get the jobs on that. But really, if you can just spend some time understanding all the base concepts, getting a job in data science is very, very easy, because we have seen so many people with just only the basic knowledges only, they got a lot of jobs, because huge requirements are there and huge good packages are also going to be there depending on your experience. And for the people who are already on some other domains, for them, is it very easy to shift into data science domains actually. So many people are learning for that particular purpose only. So many participants. So they want to shift their particular domain, their particular, the technology from existing like Java or something like they're working on some other. Even not only that, even mechanical engineer, there is nothing qualification is there. Anybody with any background, only who are interested to learn, who can understand the concepts, whatever I teach, who can learn the concepts online, those people, you can learn the particular course. Because 80% is from my side, 20-25% should be also from your side. Learning, should be learning a lot of things actually, because there are so many concepts are there. All concepts I can't cover in the class. So 80% of the concepts, I will try to cover it in the class. Remaining 20%, you have to do some kind of a self-learning. Okay, fine guys. Okay, so today's, it is my second introductory class actually, guys. So today just I've given some, just a small technical aspects of what generally we do it in our data science course. Okay, so just for today, we'll end up the session for today, guys. And we'll continue in the next class. What is the minimum salary you can expect after the completion of the course? That depends on your experience. That depends on how much experience you are showing. There are so many other factors are also will be there. Mr. Amit, right? Amit. Yeah, it's Amit. So how much experience you are putting? So how much knowledge you are getting? So it depends on them. But minimum packages, guys, even for freshers also, minimum offering on the data science is going to be minimum. They're offering 6 lakhs minimum. It's a minimum offering is going to be 6 lakhs. So we have one candidate recently. She has been got the appointment. So she is having a little bit higher experience. Her salary is going to be package is around 18 lakhs. She has got the package actually. So it depends on the role what you are working. It depends on the experience what you are putting. Again, the roles are also differs. Just give me 1 or 2 days of time. I'll just give a complete idea about what roles you are going to expect actually. Okay, we'll discuss them in the demo classes. We'll just get a clarification about all the particular job roles, what are job opportunities, all these things also we'll get a clarity about them. Okay, guys, fine. So fine, guys, just for today, we'll stop it here, guys. We'll end up the session for today. Actually, only this week I have a class at 10 o'clock. By the end of this week, it will be completed. So I have to take up the 10 o'clock. It's already 10 minutes late. So just only for this week only, guys, just up to 10 o'clock, we'll wind up the session. And then after that, we'll be having 9 o'clock to 10 a.m. 9 a.m. to 10:30 a.m. is your class timing actually, guys. Okay. So hope we'll see you all of you tomorrow, guys. Please attend the demo classes, guys. No worries about them. Attend the demo classes. Once if you're satisfied with the demo classes, then we can you can just decide whether you can continue the class, whether continue the sessions, and whether you are fit for this particular job. So can you get a job on this? What are the opportunities we have? We'll get an idea about that. Okay. So fine, guys. So thanks for today, guys. Any more questions, guys? Let us wind up the session. Yes, it is from 9 a.m. It's generally 9:10. I'll start the session, guys. Aniket. Up to 10:30 a.m. Generally, I start by 9:10, maximum 9:10, 9:15. Maximum will start up the class. Okay. Fine, guys. Okay, guys. Just for today, I'll end up the session, guys. And we'll meet up in the tomorrow's class. Same time, same link, guys. Thank you all of you, guys.